Hi everyone, this is Ms. Chow again, and we are going to explore the second half of section 5.2 in your workbooks. And this has to do with finding perimeter of a shape, and I'm assuming that the sides or the components are in polygons. So this will be fun. So in this case, the first thing it says is determine the perimeter of each figure and simplify. Well, if you don't remember, perimeter refers to the outside. So what is the outside length of an object? So we'll go about that by, and so how do you figure out the length of it, the outside length of an object? So, well, we've been given some good pieces of information. We've been given that 4x plus 8 is the length of this side. And if we know that length, then we also know the length of this side. So because those sides are the same length, because it's a rectangle, because there's 4 right angles. And then also we know the length of this side, 2x plus 3. So if we know this side length, then we also know this side length. And if we put that all together, then we can say, all right, this side, 2x plus 3. And then if we add 4x plus 8, so that's this side. And then if we go ahead, if we're going around this way, so we'll go around and we'll get all the sides. And if we get this side here, then that's 2x plus 3 again. And then if we come back around to this side on the bottom, that is, again, it's the same as the top, 4x plus 8, 4x plus 8. And I'm just writing down here because I've run out of room up there. Okay, so what we could do to simplify this is to say, okay, we have 2 of these 2x plus 3's. So I'm going to say 2 times 2x plus 3. And then we have 2 of the 4x plus 8's, right? So I'm going to say plus 2 times 4x plus 8 plus 8. Okay. And then if we do our distribution for both of these, we have 4x plus 6 plus 8x plus 16. And then if we simplify that, well, we say, okay, to simplify that, here we'll put together the x's, the 8x and the 4x, and that comes out to be 12x. And then if we do the 6 and the 16, well, that comes out to be 22. So that's our final answer, is 12x plus 22. That's simplified the perimeter of this object. Okay, so let's do another one. Here's one. Trapezoid. And the same is true with the perimeter for the trapezoid. So we're going to add together the sum of all the sides, and that will give us the perimeter. So if I add together the sum of all the sides, so I'm going to first say, here, start with the base, x squared minus 2x plus 1. And then let's go to the left. I like going to the left, counterclockwise always. To the left is 3x minus 4, so plus 3x minus 4. And then if I go to the left again, x plus 3 plus 3. And then if I go up, this is x squared minus 2. So I'm going to do plus x squared minus 2. So, and each of these polynomials represents as variables the length of the side. So we don't have the actual numbers, but we have these representations of the length of the side. So then all we need to do here is simplify. And I'm going to do that by grouping. So, no, I can't do that color. So this color. So let's take all the x squares. X squared there and x squared there. So that's 2. So that's 2x squared. And where's the 2? There it is. Okay. And then I have a 2x and a 3x, or minus 2x and a 3x and an x. So that's 4x minus 2x, so that's plus 2x. And then I need my constants, so my constants will be in red. So I have 1 and 4, minus 4, so that's minus 3, plus 3 is 0, minus 2 is minus 2. So the final answer is 2x squared plus 2x minus 2. And that is the perimeter, or the length of around this figure. Represents the perimeter of the figure. Okay. All right, let's look at a triangle. Oh, this triangle is especially exciting because it's got decimals in it. And so again, for perimeter, even for a triangle, you're going to look at the length around the triangle. So it goes up there, and then down there, and then over there. Okay. Okay, so it's going to be 3x minus 3.4x minus 2.5, I think that says. Or is it 25? I have to erase the yellow and see. It's 25. Okay. So minus 25. And then plus 0.5 plus 9. Oh, 0.5x. 0.5x plus 9. Okay. And then my inclination is to multiply this by 10 anyway, and then I can get rid of some of these decimals. So if we multiply it by 10, applying this by 10, we would have 30x minus 34x minus 250 50 plus 10 times 0.5 is 5x plus 90. There we go. Okay, so then what do we have here? We have a bunch of different things, big numbers for sure. So 30x minus 34x is minus 4x, and then minus 4x plus 5x is x. Constant, so we have minus 250 plus 90, and that is minus 160. So then we can say that our answer is x minus 160 is the polynomial version of the perimeter of this. Okay, so to figure out the circumference or the perimeter of my circle, so you're going to say circumference MCE is basically what I'm calling the perimeter. Not working so well, is it? So, perimeter in this case. E-N-C-E. Okay. And so the formula, so to speak, of circumference equals pi times diameter. And this is the diameter. Or you could say it equals 2r. So the diameter is really 2 times r. So this is r and this is r. So that's 2r pi. What we say is 2 pi r. Because 2 and pi are constants, r is a variable, goes on the outside. Okay, so then if we know that r equals 4x, well then you just simply have to plug it into the equation. So you'd have 2 pi and then 4x. And then that equals, you could say 8 pi x. There. Some of the things that it might trip you up a little bit on the homework are the fact that they give you a diagram that looks like this. So maybe it's a square or a rectangle, and then they give you half a circle, or half a circle on all ends. And so then what you have to account for is that this is just half a circle. But they may give you the radius because they may tell you this right here, which is the diameter of the circle, and it's also the length of a leg of the square or the rectangle. So you just have to remember, so if you have half a circle, that's equals 1/2 of 2 pi r. Okay, or 1/2 of d times pi, so don't forget the pi. Okay, but in this case, like for instance, one of them, number g, it gives you both halves. So actually what you can do is you can come up with, you can use both halves. You don't have to do 1/2 2 pi r, you can just do c equals 2 pi r, and then come up with the area, or the circumference around here and around here. And then that together is your whole circle. Okay, thanks very much. I'll keep going in a minute. Okay, now we are moving on to using polynomials and in the context of finding the surface area of figures. So here is a chart, and I'm going to post the chart somewhere else also, because it gives you all the formulas for surface area and volume of each of these figures. So for instance, the cylinder is surface area is 2 pi r squared plus 2 pi r h. So depending on your h and your r, you can find the surface area for a cylinder. And the same is true for a cone and a prism and a triangular prism. So what I wanted to do with you was to do just 2 examples, because your book has a bunch of examples that they'd like you to do for perimeter and also for surface area. So for surface area, so let's go on. Find the volume of a prism with length equal to, this length here is equal to 2x plus 3. So L equals 2x plus 3. And then your width is this right here, and that is 2. And your height, which is right here, and that is 3. Okay. Now I've sort of worked out the problem already here, but I'd like to go through it again with you so that we can work through it together. So the surface area of a prism, let's see, the surface area of a prism is this formula. It's 2 times the length times the width plus the height times the width plus the length times the height. So it's the length times the width plus the height times the width plus the height times the length. So it's sort of everything all together. So if we take what we know here for length and width and height and put it in that formula, so here it is, length times width. So length is 2x plus 3 times width is 2 plus height times width, or it's 3 times 2 plus, and then 2x plus 3, which is the length, times the height, or 3. And it's 2 times that whole thing. So, and that covers all the sides. So then I used the distributive property, and I distributed everything out. I apologize, I didn't put the number in the front. I put it in the back because I followed the order of the equation. But in any case, it works out to be 4x plus 6 plus 6, this is 6 here, plus 6x plus 9. And then if you simplify that, I just took away the brackets, then you get 2 times 10x plus 21. And this is, so this gives you 2 times 10x plus 21. So that's then 10x, so 4x plus 6x. And then 6 plus 6 is 12 plus 9 is 21. So that's 10x plus 21, which gives you 20x plus 42. And that's your answer, simplified. Okay, so the next one we're going to do, we're going to find the surface area of a cylinder with radius equals x, so that means this right here, this radius equals x, and the height equal to 2x. So the formula for the surface area of a cylinder is this right here. So it's 2 pi r squared plus 2 pi rh. Okay, so it's 2 pi times the radius squared plus 2 pi times the radius times the height. So you know the diameter is 2 times the radius, but I like to use the 2 pi r squared and 2 pi rh just because I've used it forever and it sounds really good to me. So anyway, if you plug in the numbers, so now you have for 2 pi, instead of r, we're going to use x. So 2 pi x squared plus 2 pi, and r is x, and h is 2x. Okay, so then we have 2 pi x squared plus 2 pi x squared times 2, or I say 2x squared down here. So 2 pi x squared from above, and then 2 pi 2x squared. Well, that gives you 2 pi x squared again, and then 2 times 2 is 4, so 4 pi x squared. And that is 2 pi x squared plus 4 pi x squared gives you 6 pi x squared. And that is that. Okay, have fun on the problems.